Okay, well, welcome back, everybody. By this time, hopefully you have watched all of the video on the properties of parallel lines, and you are ready to go, actually putting that to work. And so what we're going to do here is we're looking at the worksheet 3.2, properties of parallel lines, and in going through this with my class, one of the things I realized that as we go forward, the thing that they kind of struggled with was identifying the angle pairs. A lot of what we do from here on out, specifically when we are talking about parallel lines and transversals, we need to be going over and looking at and making sure we understand what these angle pairs are and what they mean. Okay? So there are four basic angle pairs that we talk about. And those are alternate interior, alternate exterior, corresponding, and same side interior. Now I want you guys to remember from yesterday that when we're doing this, we take one from each group of the intersection. So when we're talking about corresponding angles, we're talking about like 1 and 4. We're talking about alternate interior angles. We're talking about two and 4. When we're talking about, or 3 and 5, when we're talking about alternate exterior angles, we're talking about 1 and 6, or that 132 and 7. And we need you guys, the reason I had you guys for bell work yesterday write down all those theorems and postulates is because they're really important. They are kind of the crux of what we're doing here in chapter 3. And so you guys need to really know those. So when we're looking at 132 and trying to figure out exactly what other angles are congruent to it now or equal to it, so the given angle is 132. So we know that they are going to be congruent to it if they also have a measure of 132. So I think the easiest one to do right off the bat is going to be number 5. And so we say, 3. So we say that 3 is congruent because of the vertical angles theorem. Now, I just put vertical up there. I'm going to go back in just a second and put angles theorem. We can also look at angle 5. Now, angle 5 we can do, and we can do this because of the corresponding, there I go, see, I told you, the corresponding angles postulate. Okay? Now, the corresponding angles postulate says that when we have two parallel lines, which we do, because we have these little symbols right here, those little arrows means it's parallel, and they are crossed by a transversal, which they are, then we know that the corresponding angles are congruent. The other set of angles that are congruent are either alternate interior or alternate exterior. Here, the 132 is on the outside of the parallel lines, so we're looking at alternate exterior lines, which give us 7. And so 7 is also going to be congruent because of the alternate exterior angles theorem. Okay, so hopefully that made sense, because we're going to do it 3 more times. So moving on to number 2. So when we look at number 2, we have, so we're going to start off, we're looking at the 78 degree one right there. So we start off with that 78 degree angle. And just like we did back on number 1, I'm going to say that angle 1 is there because of the vertical angles theorem. So what I'd like you guys to do now is spend in class 5-10 minutes, however long it takes, as long as you guys are working hard. And I want you to go through 2, 3, and 4. Okay, I want you guys to identify. So remember, what the question's asking you is not just to identify the congruent angles, but also to justify your answer. Justify means tell why you're right. So not only do you need to identify that one and that 78-degree angle are congruent, but you also need to justify, you just don't need to say that, you need to justify why they have to be so. So for us, it's the vertical angles theorem. So you need a rule, a definition, something that's going to allow you to say that. So go ahead, hit pause. Go ahead and work on it, and we'll come back when you guys are ready. So you guys should be done with 1 through 4 now. And so what we're going to do is I'm going to quickly kind of run through them. Here we have angle 1. That's the vertical angles theorem. So we have 1 there. And the next one is we're going to be able to say 5. Because 5 and that 78-degree one are alternate interior angles. And the alternate interior angle theorem says that when two parallel lines are crossed by a transversal, that the alternate interior angles are congruent. And finally, we have 7 because of the corresponding angles postulate. The corresponding angles postulate says that when two parallel lines are crossed by a transversal, that the corresponding angles are congruent. Okay, so now let's look at number 3. So we're going to start off 5, vertical angles theorem, 3, corresponding angles postulate, and 1, alternate exterior angles theorem. So notice that there it was a whole lot like number 1. Same 3 theorems. Okay? Now notice that, and I did these little scribbles up top in number 1 and 2, that the perspective changes a little bit when we flip the parallel lines from a fairly horizontal orientation to a more vertical orientation. But the way that we solve the problem doesn't change at all. And how we relate the angles together doesn't change at all. So, on to number 4. So number 4, notice here that we only have 1 and 2 on the left-hand side. In the previous problems, we had always had 2 sets of 4 with the intersections. But here we only have 1 set of 4 and 1 set of 2. So when we're looking at 67 degrees, we can see that there isn't a corresponding angle. So that's out. Corresponding angle will be on the same side of the transversal and in a corresponding spot, which means in the same spot, the top left, top right, bottom left, bottom right. So here, that 67 degrees top left, there's no top left on the other side. What we can do is go, again, angle 4, whoa, jumped again a little bit there, vertical angle theorem, and angle 2, alternate interior angle theorem. Okay, and that is 1 through 4. So now, kind of going to do the same thing. I'm going to go very slowly through number 5. Set you guys loose on 6, 7, and 8. Come back, check your answers, and repeat. Okay. So, we need to find the measure of angle 1 and the measure of angle 2, and then we need to justify each of our answers. So like before, it's not enough just to say that the measure of angle 1 equals 7 degrees. I'm just saying, no, it does not equal 7 degrees, so don't put that down. We have to sit there and say why it equals 7 degrees. So here, we're going to start with angle 2. And so we're going to look at the relationship between angle 2 and that 130 degree angle. We notice they are on the same side of the transversal, and that They are in corresponding positions, meaning they're both top left. So that means that angle 2 is congruent, or the measure of angle 2 equals 132 degrees because of the corresponding angles theorem. Now, this gets messy on the drawing, but listen closely and follow along. Or no, this one's fine. Angle 1 equals 50 degrees because of the linear pair postulate. The linear pair postulate says that all linear pairs are supplementary. We know that supplementary angles have a measure which add up to 80 degrees, and that's about it. So using those as an example, I want you guys now to do 6, 7, and 8. Again, hit pause. Try that by yourself. And once either everyone's done and wants to check their answers or gets stuck and needs some guidance, go ahead and hit play again. So 6, very similar to 1, except this, again, we're doing it side to side instead of up and down. We're going to go the angle, the measure of angle 1 equals 79 degrees, and we know that because we have two parallel lines, so we can say that the alternate exterior angle theorem, I postulate it's actually a theorem, is when two parallel lines are crossed by a transversal. So here we've got our two parallel lines, we've got our transversal. And all we're saying is then that alternate exterior angles are congruent. That's the alternate exterior angles theorem. You should have written it down yesterday. We then have angle number 2. Now, angle number 2 is a little tricky because notice it's not one of the 4 that we've gone over. So we're going to have to actually kind of figure out a way to make angle 2 congruent with that 79 degree angle. We can't use corresponding because one, the one in the top left of the right-handed angle is missing a letter. And so what we want to do is we actually want to take that 79 degrees. We want to match it up with so we know that angle 1 and angle 2 are a linear pair. So we know that angle 2 has to equal 101 degrees because we simply go 80 minus 79 and it gets 100. So 79 plus 101, 180 degrees. That's the linear pair postulate. So go ahead. Right now, you guys should have already done 7 and 8, or at least try them. So 7, really the trick here is focusing in on what is the useful information. One of those lines is completely superfluous, meaning additional and unnecessary. So you want to sit there and you know that angle 1 is going to be 76 degrees because of the alternate interior angles postulate. Those are our two parallel lines, QR and TS. And then for this problem, the first one, we have that O and, or Q and, I forget whether that's an O or a T. So I think it's a Q though. So QT then is our transversal. So 76 degrees and 1 degree, those are going to be alternate interior angles. Since we know that alternate interior angles are congruent when parallel lines are crossed by a transversal, we know that the measure of angle 1 is going to be 76 degrees. What we then want to do is we don't have any other listed ones. Remember how I said that we're going to have to do this twice? Well, now what we're going to do is we're going to look at that one. So we look at that 119 and angle 2, and we realize that they are same side interior angles. They're both on the left-hand side of the transversal, that's the red line, and they are both on the interior of the two angles in the transversal. So notice that it kind of creates like a little sandwich, and it's simply figuring out that both 119 and the angle 2 are on the inside of that sandwich, the interior. And so we then should be able to look at our notes, look at the same side interior angle postulate, because once we identify it as the same side interior angles, we then need to know what does that relationship mean. We read the postulate, and it means that they are supplementary, which means they add up to 180 degrees. So we go, the measure of angle 2 equals 61 degrees. We got that by going 180 degrees minus 119 degrees. So that's going to give us that 61 degrees. And again, that's the same side interior angle. So that's where I got the 61 degrees from. It's important, I know a lot of you guys just want to write down the answer. It's important, though, that you write your steps, that you can sit there and look back. Because if you did do it wrong, you want to be able to actually see what you did and go, oh, I just tried to think my way through this problem. Anyway, number 8. So 8, we have 2 parallel lines there, and then we have 2 transversals. Okay? So keep in mind that they're not always necessarily going to transfer across. So we have those 2 parallel lines crossed by 2 transversals. So we have that 58 degrees, and we want to know, okay, well, what is congruent to 58 degrees? Actually, I guess we're going to do the other one. We're going to say what's congruent to that 82 degrees, and we go with it. Angle number 1 is, they're both top left. So angle 1 equals 82 degrees. And that's the corresponding angle postulate, which allows us to do that. Likewise, when we have angle 2 and angle 58, there we're going to kind of have to do what we did last time. We don't have a relationship that directly explains angle 2 and the 58 degrees, but we do have a series of changes which we can do. Meaning that we're first going to have to sit there and, realize that angle 2 is congruent to that angle I just marked, the one right next to the 58 degrees. And the reason for this is the corresponding angles postulate. We then know that angle right next to 58 degrees plus the 58 degrees. So I'm going to be honest with you, I just had to go and run a quick errand, so I'm not exactly sure where I left off. But so we're looking at 2 and then the angle right next to the 58. So we know that those are the 58 and the one right next to it are going to be supplementary. That means they add up to 180 degrees. That angle is then going to be congruent to angle 2 because they're corresponding angles. So we know that if we call that the measure of angle x, we know that the measure of angle x equals the measure of angle 2. Measure of angle x plus 58 degrees equals 180 degrees. Subtract 58 from both sides, and we get the measure of angle x equals 122 degrees. We can then substitute that out, and so we get the measure of angle 2 equals 122 degrees. Okay, and the reason we can do that, corresponding angles postulate, that's what let us put x and the second angle together. And then the linear pair postulate, that's the one that says all linear pairs are supplementary. Okay. So, in 9 through 11, kind of more of the same. So, again, what I really want you guys to do is focus on figuring out what these angles are, what the relationship between these angles is, and then being able to write out an equation demonstrating that. If you have two angles which are alternate interior, alternate exterior, or corresponding, you want to be able to say, hey, listen, those are alternate exterior angles, and I know that alternate exterior angles are congruent when two parallel lines get crossed by a transversal. Therefore, what I'm going to do is I'm going to set them equal to each other. Okay, so let's look at number 9. Now again, number 9, what you want to really do is focus on the necessary information. So for number 9, we have those two lines right there. Those are parallel lines, and that's our transversal. So when we look at those two lines, we should see that they are same side interior. Sorry, not two lines, two angles. And we know that same side interior angles are supplementary when two parallel lines are crossed by a transversal. And if they are supplementary, that means their sum is 180 degrees. So what we do is we'd run the math. So we start off by going x plus x minus 26 equals 180. Run the math, and we get x equals 103 degrees. So we know that top one is going to be 103 degrees. We can either figure out the bottom one by going 180 minus 103, or we can plug 103 in there, and we get 103 minus 26, which is 77 degrees. 77 plus 103 does equal 180, so we know we did it right. Again, so if we're looking at number 10, make sure you know where your two parallel lines are, those are the two black ones, and what your transversal is. And once you got that down, then you can look at those two angles, that x over 2 degrees and the 7x degrees, and go, hey, that makes sense to me. I know that those are, again, same side interior angles, which means that they are supplementary. So identify the relationship, and then write out an equation defining that relationship. Because same side interior angles are supplementary, we set them up equal to 180. Now what I'm going to do here is we have x over 2. So I'm going to change 7, instead of 7 over 1, I'm going to change that into 14 over 2, knowing that there are 14 halves in 7. So then we're going to go 15x over 2 plus equals 180. So then we're going to multiply by 15 over 2, or 2 over 15, that's the reciprocal. And remember that when we're trying to get rid of a fractional coefficient, what we do is we multiply both sides by the reciprocal of that fraction. So when we do that, we get 180 times 2 over 15, or 24. So we know that x is 24. So we can now plug that back in to find the measure of the angles, because that's what we have to find. 7 times 24 equals 168. 24 divided by 2 equals 12, and 12 plus 168 does in fact equal 180. So now moving on, we're going to go to number 11, and again, we have the two parallel lines right there, and that's our transversal. That diagonal line is completely irrelevant. So we're going to look at those angles and go, okay, what is the angle pair here? We know that 3x minus 5 and that x plus 55, those are going to be corresponding. The corresponding angles are congruent. So we go 3x minus 5 equals x plus 55. Subtract x from both sides, we get 2x equals, we're going to add 5 to both sides, 60. Divide by 2, we get x equals 30, and then plug it back in. So we'd get 85 and 85. Moving over to number 12. So again, we want to look at our x's here. Our x's are linear pairs. So that means that they are supplementary, which means they are going to add up to 180 degrees. So we go x plus 20 plus x plus 10 equals 180. We're going to math that out, and we get x equals 75. So we can now take that 75, plug it back in. 75 plus 20 is 95. And 70 plus 10 is 85. See, 85 and 95 right there. So what we're going to do next is now we're going to shift our attention over to the y's. Okay? So here, again, we see that they're corresponding. Okay? One is, or no, we don't see that they're corresponding because they're not. We see one in the top right corner and one in the top left corner. So they're not corresponding. Nor are they alternate interior, nor are they alternate exterior, nor are they same side interior. So what we're going to need to do is we're going to need to look at these and go, well, how are they related? Well, I know that if I look at just the y angle up there on the top right, I know that its corresponding angle is right there, the one that I just put the two lines on. So I know that the measure of that corresponding angle is going to be the same. So we're going to say that that's kind of the same as y. And then on the other side of that transversal, I have y minus 40. So I know that if I add those two together, I should get 180. Meaning that we don't have a direct path to them, but we can kind of back our way into figuring out that the y and the y plus, or y minus 40 are supplementary. So we just go ahead, do that math, and we get y equals 1. Sorry, not y equals 1. Y equals 110. So y equals 110. That means that this angle up here equals 110, and that this angle down here is going to equal 110 minus 40, or 70. I know, that's a z, not a 7. So that's 70. Okay. Moving on. So that went too far. So the next one's a proof. I want you guys, again, what I want you to do is I want you guys to get in the habit of at least trying these. So what I'm going to do is, about 5 minutes to try these, and then what I'm going to do is I'm going to walk you through the steps of it first, and then with kind of justifying each step, you guys can take a little bit of time and go through that. So we always start with a given. Always a good idea. Start with a given on any proof. So we have A is parallel to B and X is parallel to Y. That is given. So my second step, so hopefully some of you guys will get this, is that 4 is supplementary to 9. So I'm looking there and I see that really what I want to do is I'm going to go 4 to 9, 9 to 15. And that's my plan of attack. So I need to kind of go, well, 4 and 9 are supplementary. I'm then going to go that 9 is congruent to 15. And finally, I'm going to go 4 is supplementary to 15. So those are the steps. And notice that I got one of my steps is what I'm trying to prove. So if I can justify all my steps, then I'm good to go. So again, take a quick break, like 1-2 minutes. I want you guys to, with your study buddy, try and figure out what that step is. So why is 4 supplementary to 9? Well, we have 2 parallel lines, A and B crossed by a transversal X, and 4 and 9 are same side interior angles. The same side interior angle theorem says that when 2 parallel lines are crossed by a transversal that same side interior angles are supplementary. So we're going to call that the same side interior theorem, angles theorem. So remember what we're doing is we're taking one, so we can take 4 and 9 because we have one group there from, or we have one angle from each group. Now when we switch to number 3, A and B are no longer the parallel lines we're talking about, with X being the transversal. Now the parallel lines we're talking about are X and Y, and B is the transversal. So now we look at 9 and 15, and we can see that they are alternate exterior angles. They are on the exterior of the parallel lines, and they are on opposite sides of the transversal. So again, if you're not sure what something is, go back, reread the definition. And if you're still having trouble, come and see me. I am almost always in my room at lunch, and I am almost always in my room after school till at least 4 o'clock, unless I'm working with a student who needs more time. If any of you guys ever have questions from now until the end of the year, feel free to come by whenever. Okay, so look at the number 3 now. That would be the alternate exterior theorem. And then finally we have 4 is supplementary to 15. And I don't know whether you guys went over this or not, so I'm just going to give it to you. It is, if we know that 4 is supplementary to 9, and that 9 is congruent to 15, then we can switch out 9 and 15, and that is actually a version of what is called the congruent supplements theorem. Now the congruent supplements theorem actually says, the congruent supplements theorem actually says that if 2 angles are supplements to the same angle, then they are congruent to each other. And we're using the converse of that, so we're flipping it around. And we're saying that if 2 angles are congruent, 9 and 15, then they must be supplements to the same angle. So, like any good definition, it is true forward and it is true backwards. So, now what we're going to do is we're going to look at 14. I don't know. So 14's out there in the margins. When we have 2 sets of parallel lines, we know we can sit there, and what we're looking for is to kind of match up those 4 pairs of interior angles. If one of them's 60, then it kind of falls out that way, and you can just match them up with, first by talking about, either linear pairs or same side interior angles, so you know that the supplementary angles are going to be 60 and 120, and then we can match up the congruent angles by identifying the alternate interior, alternate exterior, so on and so forth. So, what I want you guys to do, error analysis. This is really important. You guys need to be able to sit there and look at something and go, hey, listen, this doesn't look right. So the error analysis, which solution for the figure at the right is incorrect? Okay, so we have 2 sets of angles, and they are written one as being supplementary and one as being congruent. Take a couple minutes, figure out which one's incorrect, and so hit pause and then come back to this. So hopefully you guys all saw that these 2 angles, incorrect, are, you were able to identify these 2 angles as alternate interior angles, which means that they are congruent. Okay, so since they're congruent, we can sit there and say that this is the right one, which means that the one on the right was the incorrect one. So now we have this nifty word problem for 16, and I'm really, again, what helps here is being able to look at the word problem, transfer it into what you're used to seeing, and then solve it. So a zip line consists of a pulley attached to a cable that is strung between two objects, and the zip line at the right one end of the cable is attached to a post parallel to the tree. What is the measure of the angle? What is the angle pair? And how do one and the given, what do they represent? Okay. So here we know that those two lines are going to be parallel. We know that then the zip line represents the transversal. So we know that that 115 right there and that 1 right there, they're going to be alternate interior angles, which means that they are going to be congruent, which means that that right there is also 115 degrees. So thank you very much. Sorry if I was a little incoherent at time. I'm really tired, and it is really late, but it's worth doing this for you guys. So I hope these help. And again, if you need any help, come and see me. I'm in 202B. Have a wonderful day, everybody, and I'll see you on the next video.